Hello and welcome to part 2 of the interim test review. We'll be going over sections 6 through 10 here. All right, so let's get right into it. So the first section is solving systems of equations. We learned 3 ways to solve systems of equations: graphing, elimination, and substitution. The first example here is the graphing. Remember, the solution to the system is where the two systems intersect. So x is, on this problem, the two lines do never intersect because they are parallel, which means that there is no solution. For C, I'm going to use substitution to solve it. What I'll do is I'll take this equation, but instead of writing y, I'll write what y equals. Now, however, when we combine like terms, they cancel, and so we'll get 10 equals 4. That is not a true statement. Whenever you get an untrue statement and all the variables have gone away, then that means it is no solution. And if you were to graph these two lines, they would look like the example here in B. Not exactly like that, but they would be parallel. All right, for D here, I'm going to use elimination. I'm going to eliminate one of the variables. In order to eliminate one of the variables, we need the coefficients of x or the coefficients of y to either be the same or additive opposites. And so what I'm going to do is I'm going to multiply the second equation by 3. Sorry, that's unclear. I'm going to multiply the second equation times 3 so that I get 3x minus 3y equals 15. That way, when I add the two equations together, I'll get 5x equals 21. Divide both sides by 5, and I'll get x equals 4.2. Then, I know that 4.2 minus y equals 5, because that's the second equation. And so I'll subtract 4.2 from both sides, and I'll get negative y equals negative 0.8, or y equals 0.8. So my solution is 4.2, 0.8. All right, now we're going to get into some word problems. And for most people who do systems, the hardest part of these is creating the equations. So the sum of two numbers. Sum means add. So the sum of two numbers is 14. The difference, subtract, of two numbers is 28. So I will notice that the coefficients of y are additive opposites, 1 and positive 1. So I will use elimination, and I'll get 2x equals, that is 42. Divide both sides by 2, and I'll get x equals 21. And 21 plus y equals 14. So I subtract 21 from both sides, and I'll get y equals negative 11. So my two numbers are 21 and negative 7. During a sale, Ted sold a total number of hats and shirts of 56. He sold a total of 56 hats and shirts. So hats plus shirts equals 26. If he sold 34 more hats than shirts, So here's where you have to think about what the equal sign means. Are hats and shirts equals? No, they need to balance. He sold more hats, so in order to make them equal, I have to add 34 to the shirts. And now the number of hats and shirts are equal. So now I can use substitution. S plus 34. Actually, here, I'll color code this just so we're clear. So I will do S plus 34 plus S equals 56, or 2S plus 34 equals 56. Subtract 34 from both sides, and I'll get 2S equals 22. Divide both sides by 2, S equals 11. So the question asks, how many shirts did he sell? He sold 11 shirts. All right, for G, these are systems of inequalities. So to graph the first one, the y-intercept is -3 and the slope is 1. And it's less than or equal to, so I will get a solid line. For the second one, the y-intercept is 0 and the slope is -1. But it is less than, so instead of a solid line, I will get a dotted line. Now, I'm actually I'll change this to green just so we're all clear. So the black one is y is less than. So I would put my pen on the line, and I know I'm going to be shading down from this line. The green line is greater than, so from this line I'll be shading up. And so the only region where both of those are true is this region right here. For this next one, once again, graph the first line. The y-intercept is -2, but the slope is 5. And remember, we can write that as 5 over 1. And so that means go up 5 and over 1. And then I'll repeat that. This is going to be a dotted line. And I'm going to be shading down from the line. Now, a lot of times people get confused about shading up or down because all they see is left and right, not up or down. And so my recommendation is put your pen on the line and go down, and that's the half you would shade in. The other equation is y-intercept is 2, slope is -6. This is also going to be a dotted line. And once again, I am shading down from the top line and up from the back line, so the shaded region will be here. All right, next we have direct and inverse variation. And the key to this is that direct variation is y equals k times x. And inverse variation is y equals k divided by x. K is the constant of variation. And so you need to know those two formulas. Then once you do, everything else is easy. So for A, it says assume y varies inversely. if y equals 14 when x equals negative 2, what is k? So now we just solve for k. Multiply both sides by negative 2, and I get k equals negative 28. This is the same problem, except for it tells us that it's y varies directly. But I'm still going to plug in y is 25. And x is negative 2. So to solve this, I would divide both sides by negative 2, and I get k equals 12.5. Because the constant of variation is k. All right. On this one of the key things to understanding these problems is that direct variations always go through the origin. So if they give you a problem like this, the first point you can put in is the origin. But it asks us for 2 points. Well, there's our first point. And remember, direct variation is a straight line, so the slope doesn't change. So to go from this point to this point, I go up 1 and over 2. So I get another point, I go up 1 and over 2. And that would be C. If I want to keep going, I could give that D. Heck, I could come back here and make that E. As long as we formed a straight line going through the origin. So here's another one. Once again, our second point is the origin because it tells us it's direct variation. And then our next point would be there, and just keep the pattern going. All right, so for these where it says determine if each table is a direct variation or an inverse variation. One of the key things is in a variation, k is a constant. It does not change. So we had inverse variation, we said was y equals k divided by x. But if I solve that for k, an alternate form of that is k equals x times y. So if I take a table and I do x times y and I get the same number each time, say like right here, but here I don't get the same number. So this is not inverse variation. Let's try this one. This is 24. This is 24. This is 24. So this is inverse variation. Here, this is multiplying them. That's 18. That's 18, but that's negative 18. So that is not inverse variation. Now, direct variation, we said was y equals k times x. So the alternate form of that is k equals y divided by x. So if I do y divided by x, and I always get the same thing, then that's direct variation. Here they're not the same, so this one is neither or neither, depending on how you want to pronounce it. All right, next up is scatter plots. We're going to be using the calculator a lot here. Luckily, I have one, maybe. There it is. We'll come back to that in a second. So we want to enter in the data here. It says the table shows you the number y of alternative fuel vehicles in the United States, y in thousands, after 1997. Approximate the best fitting line for the data. So a couple things we need to do is this is 1997. So this would be 1998. This would be 2000. The other thing is this is not 280 vehicles, it's 280,000 vehicles because it told us y is in thousands. So we are going to put the data in. So if you want to put the data into your calculator, what you do is you hit Stat, Edit. If there's already data in there, you want to clear it, not delete it. clear it. And then we put the data in. 0, 1, 2, and that's 280, 295, 322, 395, 425, 471, 511, 548. So now we have the data in our calculator. So how do we find the equation of the line of best fit? So we do stat, hit the stat button, and go over to calc and choose the line of regression. X's are in L1s. Yep. Y's are in L2s. We're good. And so we will just go ahead here and click calculate. And so, whoops, come back. So what we will see here is that our equation then is going to be y equals 40.869x plus 262.833. In the absence of instructions, go to 3 decimal places. That's the AP Calculus standard, I believe. So then it says estimate the number of fuel alternative vehicles in the year 2014. So here's where it becomes important, is that years since 1997. So 2014 minus 1997 is 17. So that's the number I'm going to plug in for X. So Y equals 40.869 times 17, because it's 17 years after 1997, plus 262.833, and I get Y equals 957.61. But it's important to remember that that's really 957,610 vehicles. Let's go to the next one. I don't need the calculator this, so we'll go back to full screen. So for this one, all I would do, actually let's not go full screen, is I would draw in what appeared to be a line of best fit for myself. Then the question was about how many service regions are used when there are 100 million subscribers. So 100 million subscribers is right there. The answer would be, you know, around 98,000. Just taking our points off the graph. Okay. So going back, this is, actually let me just fix this a little bit. I feel like this could be a little bit smaller so we can all read it. All right, so use the table below to answer the questions. Write the equation of the line of best fit. So we're going back to our calculator here. We're going to go stat, edit, and we're going to clear out our data that was already in there. Clear, enter. And we're going to go ahead and put the data in. So 3 and 16, 7 and 45, 10, 15, 18. And we'll get 45, 82, 102, 116. Remember, we're making sure that we have the X values. Making sure we have the X. It's not writing, that's okay. Make sure we have the I give up on that. The x values in L1 and the y values in L2. So write the equation for the line of best fit on the table. So we'll just go stat calc line of best fit, calculate, and I will get y equals 6.711x plus 1.066. And so then estimate the x value and y equals 125. So I'll get 125 equals 6.711x plus 1.066. Subtract 1.066 from both sides. I'm going to need the calculator for that. And I'll get 123.934 equals 6.711x. Divide both sides by 6.711. And I get my answer is x equals 18.467. All right, Bill rode his bike to a store 5 kilometers from his house. The table shows the distance from the store paired with the number of minutes after leaving his house. Right? As the longer he rides his bike, the closer he gets to the store. Which curve of best fit best represents the data in the table? Now, all the curves you will notice are straight lines, so we can use our line of best fit. So once again, we're just putting the data in the calculator. And it's 0, 3, 4, 3, 5, 8, 5, 4, 3.2, 1.9, and we do stat calc line of best fit. Calculate. And so our equation is, so which one of these is closest to what's in the calculator? And if you look at it, the answer is C. Because if they're going to go to one decimal place, we need to round. So if you look over here, this would round to negative 0.4, and this would round to 5.1. All right, so we can close out the calculator now. All right, so section 9, last section, writing equations of lines. Or no, sorry, we got 2 sections left. We got 9 and 10. Writing equations of lines. So it says write the equation for the line below. So to write an equation, we need 2 pieces of information. We need the y-intercept, and we need the slope. So we find 2 points where the line goes through a clear intersection of x and y integers, and we see that the rise is 3 and the run is 2. Remember, slope is rise over run, with my intentional misspelling of rise, so remember the y goes on top. So my slope is m equals 3 over 2. And just as a quick double check for yourself, remember that lines that go up like this line, the slope is positive, but over here the line's going down, so the slope will be negative. So y equals mx plus b. So for this line, y equals 3/2 x minus 3. Over here, same process. The y-intercept is 5. It goes through that point down there, and that's going down 3 and over 2. So that'll be a negative 3. And so y equals rise over run. So it's just the slope. X plus b. All right, write an equation for a line that has a slope of 2 and passes through the point negative 5, 8. So y equals mx plus b. But they didn't give me, they gave me the slope. They didn't give me b, they gave me a point. So I know that when x is negative 5, y is 8. And I know that the slope is 2, so the only thing I'm missing is b. So I'll get 8 equals negative 10 plus b. Add 10 to both sides. I get b equals 18. So my equation then is y equals 2x plus 18. Right here it says write the equation for a line that passes through the origin. Well, that gives me two pieces of information. It gives me a point on the line, and it tells me that the y-intercept is 0. So all I need to do is figure out the slope. And there's a couple different ways you can attack this, but remember that slope equals the difference in y's over the difference in x's. So x1, y1, x2, y2 equals 6 minus 0 over 2 minus 0. I'm sorry, that's upside down. Apologize. 2 minus 0 over 6 minus 0, x's, which is 1/3. So my equation is going to be y equals 1/3 x. Notice that there's no plus, we don't write plus 0. And also this is a direct variation because it goes through the origin. Write an equation for a horizontal line. So horizontal means the line goes like this. If the line goes like that, the y does not change. And since it goes through a y value of 7, that means the equation for the line is simply y equals 7. In a vertical line, looks like that. The x does not change. So this is just x equals -4. All right, last section, graphing lines. So graph the linear equation below. So slope is 3/5. The y-intercept is 2. So I start at 2, and I go up 3 and over 5. And if I wanted to, I could go back 3 and back 5. And then draw in my line, and I'm good to go. Now we just talked about this one. This is y equals -3. Y does not change. It is a horizontal line through y equals -3. All right, so C is not solved for y, so it's not in y equals mx plus b form, so I will solve it for y. I'll subtract 3x from both sides, and I'll get 4y equals -3x plus 12. Then I'll divide everything through by 4, and I'll get y equals -3/4 x plus 3. Now I know that my slope is -3/4. I know that my y-intercept is 3. And there's my line. Remember, lines with negative slopes go down. Here it's the same thing. I'll add 2x to both sides, and I'll get -3y equals, don't forget the negative, a lot of people do, is 2x plus 12. And I divide everything through by -3, and I'll get y equals -2/3 x. Hold on one second, just double checking my work here. -4. So my y-intercept is -4, and I'll go down 2 and over 3. And there's my line there. Graphing inequalities. It's the same thing as graphing a line. If it's less than or equal to, it's a solid line. If it's greater than or less than, but not equal to, then it's a dotted line. So, but otherwise, we do the same thing. We say the slope is 1/2, and the y-intercept is -3. But instead of drawing a solid line, oh no, on this one I will draw a solid line, so I draw my solid line in. And then we look at it and we say, okay, x is less than or equal to, so I will shade in the area below the graph. And any point that lies in that region is a solution. For y is greater than 5x minus 2, y-intercept is -2, the slope is 5. But this time it's going to be a dotted line, and y is greater than, so I am going to shade up. Now once again, it's that whole left-right thing, so put your pen on the line and go up, and this is the part that you will shade in. Now if you points on the dotted line are not part of the solution. That is the only tricky thing about this. There we go. All right, and so that is, oh, almost done. We got 2 left. Identify the slope and the y-intercept. So all this is asking us to do is to solve for y. So I'll get -4y equals -2x plus 12. Divide everything through by -4. And I'll get y equals 1/2 x minus 3. So the slope is 1/2. The y-intercept is -3. Same thing. This one is tricky though, because there's an x, but there's no y. So what do we do? Well, if I multiply both sides by 8 there, oh, I need my calculator again. I get x equals 120. But x equals 120 is going to be a vertical line. So the slope is undefined. And there is no y-intercept on a vertical line unless it's y equals 0. And so that's it. Hopefully you enjoyed this section, or at least survived it. And if you have any questions, make sure you have them for your teacher next class.